Okay. So an actuary studying the insurance preferences of automobile owners makes the following conclusions. An automobile owner is twice as likely to purchase collision coverage as disability coverage. So the probability of collision would be 2 times the probability of disability. The event that an automobile owner purchases collision coverage is independent of the event that he or she purchases disability coverage. Okay, so the probability of C intersection D, right, is equal to, since they are independent, it's equal to the probability of C times the probability of D. The probability that an automobile owner purchases both collision and disability coverage is 0.15. So the probability that they purchase collision and disability is equal to 0.15. Calculate the probability that an automobile owner purchases neither collision nor disability coverage. So they don't purchase, so let me put it all the way down here. So we want to find the probability that they don't purchase collision and they don't purchase disability, which is the same thing as the probability of C union D complement, which is the same thing as 1 minus the probability of C union D. Okay, and I know that is equal to 1 minus the probability of C plus the probability of D minus the probability of C intersection D, right? Which I know what probability of C is, right? This is equal to 1 minus, so that's 2 probability of D plus probability of D minus C intersection D is 0.15. Okay, so this is equal to 1 minus 3 probability of D plus 0.15, because minus minus is plus. So far, we know that what we're looking for is equal to 1.15 minus 3 probability of D. Okay, so now let's go ahead and try to find the probability of D from what we have here. So we know that 0.15 is equal to the probability of C intersection D. And since they are independent, we know this is equal to the probability of C times the probability of D. And this is, we know that probability of C is the same thing as 2 times the probability of D. And this will be times the probability of D. All right. So what we get is 0.15 is equal to 2 times the probability of D squared. And what we can do is we can divide both sides by 2 to get 0.075 is equal to the probability of D squared. And then we can take the square root of both sides to get the square root of 0.075 is equal to the probability of D. Okay, so now we actually have what we need, all right, which equals 1.15 minus 3 times the square root of 0.075, right, which is equal to 0.3284. So if we go up here, 0.3284, that is close to B.